Okay, what's the chapter name? Angle and cyclic property of a circle. Fine. We have around 6 to 7 law students. Angle and cyclic property of circle. Before this, are you thorough with isosceles property? Isosceles triangle, equilateral, lemma, Sharisha, Joanna. You know about types of triangles, right? Okay, is Lemula online? Can you talk a bit loud, Lemula? Why is your voice so low? Yes, you are attending, right? Okay. So concentrate. This is a tough chapter, students. You have to remember the properties. Look, angle and cyclic property of a circle. This is nothing but in a circle you'll have certain angles formed. In a circle you'll have certain angles formed. According to that, there are properties. They have given few properties. Now, what is the basic concept here? This is a circle. What do you call the outside value? What do you call this entire outside part? All of you should unmute and answer. What do you call it? Like we call perimeter, right? For circle, what do you call? Yes, circumference. For circle, it is circumference. Next, the center. Let us take a center point here. O. I'll name it as O. From here, if I touch the circle, what do you call this line? Radius. So there will be multiple radius, students. You'll have multiple radius. Only one line we call radius. Fine. So the same thing. If I stretch this side, what do you call? Diameter, right? Two radius put together. Diameter will be in a straight line, AB. I'll name it as AB. So AOB is a diameter, straight line. A diameter will pass through the center like this. Like this. CD. All this is diameter. It will touch both the circumference part. You call it as boundary or circumference. It should touch both the circumference with by passing through the center. That is what you call diameter. Next, which doesn't pass through the center but only touches the circumference. What do you call this? Call it as chord. Very good. This is chord. This any 2 points which touches the circumference, we call it as chord. And in chord, very important concept. We have two properties. Next, diameter is also a chord. Diameter is the longest chord. Which one is the longest chord? Diameter. Okay, diameter AB. I'll name it as AB. This is the longest chord, students. Longest chord. Or the length of this chord is the highest. If you compare other chords like this. See? If you compare like this, diameter is the longest chord. Next, these are things you have to remember: circumference, radius, diameter, chord. Next, in a circumference, what do you call a part of circumference? What do we call a part of circumference? Only this part? No, no, this is not semicircle. Is it semi-half circle? Naomi? This will we call it as arc. What is semicircle, Naomi? Semicircle means half of the circle. from diameter half. This is known as semicircle. Semi meaning is half. Okay, well that is important. Full circle, semicircle. Both the things are important. Full circle, semicircle. So first property, it is related to arc. Look here, we need arc here. Any two shortest distance on a circumference, we call it as arc. Now from arc, I'll connect to the center. What are these two lines? Lemma. What is OA and OB? What do you call? Talk a bit loud, Lemuel. Answer a bit loud. Call it as radius, right? AO and OB are radius. And what about AB? What is AB? A circumference, the entire thing. What are you doing, Lemuel? When I'm teaching, you're not concentrating. Just a part of circumference, what do you call? We call it as arc. When radius and arc is put together, we call it as sector. What do you call? Sector. We have sector and segment. Segment is nothing but arc plus chord. What is sector, students? What is sector? Sector is arc plus radius. Look at the word arc given here. Lemula, concentrate. Next time I won't teach. If you're giving wrong answers, I don't care. R stands for radius. Sector. Segment is made up of what? Segment is made up of arc and chord. Now let me take CD. What is CD? Is it arc or a chord? CD is a chord. Now from chord, if I touch this center, what is OCD? Triangle OCD, students. Triangle OCD is made up of what? It is made up of chord plus radius. Chord plus radius. R plus we need chord. Sorry, this is radius. Actually, both. Okay, it's just a triangle. It's just a triangle. Now let me take a arc. Look, let me take arc BC or CD, students. Let me take CD and I'll touch like that and name it as E. What is CE? Is CE radius or chord? CE. Line CE. What is line CE, students? Is it a chord or radius? It's a chord, right? It's touching from one circumference to the other. It's a chord. What about arc? Lemula in the next triangle. What is which one is the arc in CED? CED, which is the arc. What do you mean by arc? CD is the arc. So what is this, students? What is the center triangle? We call it as segment, right? What is CED known as? CED is known as segment. Then which one is sector here? Which triangle is sector? CED or AOB? AOB is the sector. This is the difference. Make a note of this. Take down what is sector, what is and segment. A sector is made up of radius and arc. Segment is made up of arc and chord. Is it clear, Joanna? Did you understand? All four of you, did you understand the concept? Right. We'll start with the theorems. Okay, students. Center A, B, O. What do you call this? A O B. Observe clearly and tell me, is it a sector or segment? A O B. How do you identify difference between sector and segment? Okay, what is this? Then what is this? Does it have a chord or a radius? That's the radius. Unmute, all of you will unmute. Keep it unmuted. Joanna, Terisha, Lemuel and Naomi. Yeah, don't mute the call, students. You'll take too long. Don't mute the call. Okay, then what do you call this? Is it sector or segment? You call it as sector. So theorem one. Theorem one is, see, this is a segment sector. In sector, we have chord, radius, radius plus arc. Which is arc here? Which is arc? AOB or AB? Which is arc here? AB is the arc. Fine. Look here. AB is the arc. Now I'll draw another triangle like this. ACB. What kind of triangle is ACB? What do you call sector or segment? What is ACB, students? ACB. Look at CB and AC. Are they chord or arc? I mean chord or radius? AC and CB. They are segment, right? They are chord. So it is a segment. So ACB is a segment. AOB is a sector. Is this clear? Did you understand the difference? AOB. Now the formula is, whenever you come across both a triangle, okay, both are triangles, and what is the common triangle? How do you name this, students? You name it as AOB, and the other one, how do you name other triangle? How do you name the other triangle? ACB. Yeah, whichever angle, wherever angle is formed, that should be in center. Look here, O is center, C is center. It should be written in center. Fine. So we are concentrating on angle O and angle C. They are in center. For both, what is common? Which two alphabets are common? AB is common. That is the arc. That's the arc, right? Or if I draw a line like this, if I cut A and B, isn't it the base of two triangle? it becomes the base, right? So you can call AB as base or arc. It's the same. But here, just because circle is given, in terms of circle, we call it as arc. So if it has same arc, if any two triangles have same arc, then the formula for this is, where is AOB formed? Where is AOB formed, students? In the center or circumference? AOB is formed in the center. So the value of AOB will be twice the value of triangle ACB. Or you can even remember center. The angle formed in the center will be twice angle formed on which one? Where is angle C formed? On the circumference. Is it clear? Angle formed on the circumference. If not, the other way you should remember, what is AOB? Sector or segment? AOB is sector. Angle formed in the sector is how much? Is twice the angle formed on the segment. Which one is easy? The second one is easy to remember, right? Whenever angle is formed in the center, it is twice the value of circumference. Is it clear? You have to remember this. So this is first theorem, which has a sector and a segment. So don't remember theorem 1, theorem 2. Remember whenever sector and segment is given, which has same arc. When they have same arc. So what's the answer for this, students? For if example ACB is 50 degree, what's the formula? Tell me the formula, what you have to remember. Center is equals to twice of circumference. Yes, twice of circumference. What is center angle formed? Tell me the angle formed in the center. AOB is equals to twice angle ACB. Which value is given? Which value? And then what will be the value of angle AOB? ACB is 2 into 50. 100 degree. Is it clear? All four of you, did you understand? Is Joanna online? I'm not able to hear your voice. What are you doing, Joanna? Like this? This is for, okay, complete it. What choir practice you have been to? Is it in school? Every day you have taught it? Every day there's choir practice. Oh, okay, only today you will have special, today or maximum tomorrow I might conduct. Only 2 days of special class. Oh. See, remember this, students, angle subtended. Look at page number 280. All of you open page 280. Page number 280. Can you see the first thing given? Angle subtended at an arc. Angle subtended by an arc at the center. Forget about the theorem. Just remember the word. I've just taken main words. Center is equal to what is given here? Double the angle subtended at the circumference, right? Remaining part meaning is circumference. Adya, what time I told you to attend? What is the time you're attending? Is it 5 o'clock? Anyway, I've started Adya. I'll send this recording. I can't keep teaching again. Continue from here. Just because you were absent, I told you to attend for special class and log in at 5:30. You can go through the recording, Adya. I'll send this later. All of you are done? Done with the first theorem? Yes, Adya. See, you might not remember, Adya. Definitely, you might not remember. Continue from the next topic. This you go through the recording. It's a tough concept. All of you are done? Understood the difference? Yeah. So this is the first theorem. Now look here. The same concept. I'm spending time and I'm taking special class. I told you yesterday. In spite of that, you're joining late. Okay. Now tell me two triangles. What are the two triangles formed, students? All of you are unmute and answer. What are the two triangles formed? Triangle triangle POQ and triangle PRS. Okay, look at triangle POQ. Just imagine there is a line here. This is a triangle POQ, and imagine I draw another line here. They won't give lines like this, but just imagine PS is a line. So PRS is a triangle. Where are these two angles formed? POS is formed where? Center or circumference? It's formed in the center. Angle POS is formed in center. What about PRS? PRS is formed in circumference. But do they have same base? Do they have same arc? PQ and PS, are they same? Is the arc same here? No, right? Arc is different for both. So therefore, theorem one doesn't cannot be applied here. Is it clear? You can't apply theorem one, students. Center is equals to two times circumference. You can't apply that concept because the base is not same. Okay, the base is not same. It's very simple. The arc should be same. Arc is nothing but the base. A, B, C, B, O, C, like this. Remember like this. Any triangle which has same base, BC and BC, which has same. If A is formed in the center, if triangle A is formed in the center, and angle O is formed on the circumference, then what is theorem one says? What is theorem one? Center is equals to twice circumference, right? Center is equals to twice circumference. This is the formula. Next concept. See, one concept theorem is related to center, center and circumference. One theorem. The next theorem is related to two circumference triangle, two triangles formed on the circumference. That is two segment. Let me take like this. Okay, now tell me what are the two triangles formed, students? What are the two triangles formed? All of you unmute and answer. What are the two triangles formed here? What are the two triangles we have? Let me draw like this. Nobody heard the question? Joanna, Adia, Charisha, Naomi, POQ and PSQ, right? POQ and PSQ. Look here, let me write triangle PSQ and triangle POQ. Where are these two triangles formed? In the center or circumference? Both the triangles are formed on circumference. Okay, good. What is the common base for them, students? What is the common arc for both? PQ is the common arc. So therefore, here we have second theorem that which says when there are two segments, look here, PQ is the common arc like this. Now let me cut PQ. You'll get a triangle here. Is this clear? Did you all understand these two triangles? PSQ and POQ. Okay. In this PQ is the base, or you can call it as arc. You can call it as base or arc, which has same arc, students. So look here. In triangle PSQ, what do you call this? Is it a sector or segment? PSQ is a sector or segment? Segment. What is segment? Adya, do you know segment? What is segment? No, that is wrong. Okay, what is POQ, student? Sector or segment? What is formed here? What is OP? OP and OQ? Chord or radius? Chord, right? OP and OQ are chord, so therefore it is segment. See, we have two segments. And does both the segment have the same base, PQ? Both the segment have same arc, PQ, right? Fine. Adya, you do one thing. You can log in at 6:30, Adya. Yeah, you won't understand this. I'll send recording. If not, you have to skip the chapter. That's it. There's no other choice. You can log in at 6:30. Anyways, you won't understand whatever I'm teaching now. Yeah, you better log in at 6:30. Not 6:30. 6 o'clock, Adya. No, let her log in. See, this is what happens, students. If you join late, 5-10 minutes is fine. Half an hour late, 40 minutes late, you'll have to leave. Leave and join the next class. Okay, from here we have two segments. So these two segments is from here we have theorem 2. So theorem 2 is nothing but whenever two segments are formed and has the same arc, which means these two angles will be equal. If angle PSQ is 50 degree, then what about POQ? 50 degree. So you have to write PSQ is equals to angle POQ. That is angles of, is this segment or sector? These two are called segment or sector. Angles of same segment. Take down the theorem. This is what you have to write in the bracket. Make a note of this. Angles of same segment. We call it as angles of same segment. See, both are formed on circumference. You can even remember like this. Circumference is equals to circumference. Is it clear? Joanna, Lemuel, Naomi, Charisha? So don't blindly write theorem 1, theorem 2, students. 1 and 2, the name doesn't matter whether it's theorem 1 or 2. You should remember the concept. Segment, segment, segment and sector. So angles of same. You have to write the reason. Angle of same segment. That's it. Okay, I'll give one question. See, this is a circle, this is a sector. Okay, I want you all to answer. All of you are unmute. First, tell me how many triangles are there, students? Tell me how many triangles? Three triangles. What are those three triangles? P, Q, R, and P, R. Lemula, you don't know these three? Naomi, Lemula, Joanna. Only Cherisha is answering. I'm not able to hear you all answering. How many triangles are formed? Three triangles. PSR, PQR, and POR. In these three triangles, what is PSR? Segment or sector? Okay, Lemula answer POR. What is POR, Lemula? Segment or sector? What's the reason? Chord plus what? What is chord in that? In POR, what is chord? It's OR and yeah, only one chord. Is PR also a chord? A triangle has only OR like this. Only these two parts you can see. PO is also chord. You can't observe Lemula. You can't observe one more line. Or you want to leave? Want to leave and join at 6:30? Only two things, Lemula. I'm teaching you all. Concentrate, understand, do it. If you're getting confused, you have to concentrate when I'm teaching. If your thought is somewhere else, you won't be able to understand. As simple as that. If not, you have to skip this chapter. Tell me once again, what is POR? Segment. What is confusing in this Lemula? Tell me, which part is confusing? If I tell if you tell POR, which three lines you have to see? By the word itself, you have to check PO and R. You tell POR, is it correct if I just round up and if I draw some diagram? Is it correct? No, right? So you have to observe. When I'm teaching, you should your thoughts is elsewhere. You're just thinking of something else. Then when I ask questions, you're not able to answer. Now tell me what is PQR, Naomi? By sector, which two is R? PQ and QR. Understood? There will be three sides. In that one is R, the other two is radius. Fine. What are the theorems we have? Can you tell me the theorem? For sector and segment, do we have some theorem? Lemula, Joanna, answer the first theorem, students. Tell me the first theorem. For sector and segment, I gave a theorem. Or which angle is formed in the center? Which angle is formed in the center? Center is equal to twice circumference. Which angle is formed in the center? So PQR is equals to twice. Which angle is given here? Which value is given? POR is given or PSR? So you have to take PSR first and solve it. This is how you have to solve. You should observe the triangle, what is given, whether it is a sector or segment, whether it is formed in the center or circumference. Now tell me the value of PQR. What will be PQR? 2 times what is PSR? So that is 80 degree. Which is 80 degree, sir? PQR. So this is the concept PQR. Next, Lemula, tell me POR. How is POR and PSR related? They two are what? They two are triangles. They two are triangles to both a segment. So what's the rule I told? If two segments are there and if their arc is same, will the angle be equal or different? Equal. So which two angles are equal here? Angle PSR is equals to PR. Simple. That's it. Angle PSR is equals to PR. So what's the value of PR? 40 degrees. Make a note of this. All of you all complete it. Any doubts? All four of you all, did you understand the difference? Oh, PQR, PS. So this will be 40 degree, this will be 80 degree. And you're supposed to write it like this, student. PSR is equals to PR. And what's the reason you all have to write? Is it a sector or segment? PSR and POR. Segment. Both are angles of the segments, right? Angles of same segment are equal. Angles of same segment are equal. That's it. See, whatever I told, just write it. Angles of same. I told angle of these two segments will be equal. So very important concept. You should know what is sector segment. Angles of same segments are equal. Fine. The next theorem is of semicircle theorem. Angle formed on semicircle will always be equal to 90 degrees. Take down the third theorem. Third theorem it says, look here students, let me draw a semicircle. What do you call this semicircle? We also call it as chord, diameter, right? We also call it as diameter. AB is a diameter. This AB splits this circle into how many halves? AB splits this circle into how many parts? Two parts. Yeah, it's split into two parts. Now, on a diameter, any angle formed on the circumference. Tell me what is formed on the circumference here. Which angle is formed? Angle ACB. So from the diameter, students, remember from the diameter, if any angle is formed on the circumference, angle ACB will definitely be equal to 90 degree. Will be equal to how much? 90 degree. You have to write the reason angle formed on semicircle. Isn't it formed on the semicircle? Right? It's formed on the semicircle. Yeah, full circle, just ignore this. Okay, now it becomes a semicircle. Just ACB is a semicircle, and the other half is this, the pink one, green one, pink one. So the angle formed on the semicircle will be 90 degrees. Now let me draw another triangle here. Same diameter. On diameter AOB. What's the other triangle formed? What's the other triangle formed? AO. What will be the value of AOB? Even AOB will be 90 degrees. You take anything, students, from AB, you draw n number of triangle. N number of triangle. Next, APB. What will be the value of APB? APB will also be 90 degrees. Is this clear? APB 90. Angle formed. You have to write the reason, angle formed on semicircle. That's it. Angle formed on the semicircle is 90 degrees. Okay, this semicircle concept, it can be like this. Okay. A circle, center like this. Is it a diameter? Yeah, it is a diameter. It is passing through the center in vertical way. So what will be the angle formed here? What will be the angle formed? Angle C will be, what is angle ACB, students? ACB is equals to 90 degree. Angle formed on the semicircle. This is the third theorem. Joanna, did you understand all three theorems? Hmm. Next comes the main concept, cyclic. Fine. Another 5 minutes. You'll take break. Let others join. 7 o'clock will continue. I mean, not 7, what? 6 o'clock. Let others join. We'll continue with the other topic. Fine. Once again, I'll make you all revise. We have 5 theorems. Okay, we have 5 theorems. Lemula, can you respond? Lemula, are you online? Yes. Okay, I've already taught, I've explained for students. Others, I know, others will remember the concept. Once again, I'll just quickly explain. We'll start solving the questions tomorrow. Angle and cyclic property. Today, only the theorem part. Fine. What are the 4 theorems we have? Before that, students, before that, I want all of you all to answer now. I want all. What you call this outer surface? What you call this outer surface? You call it as circumference. Circumference. And a center. From center, if it touches, what do you call this line? You call radius. Circumference, radius. Next, this radius. We'll have n number of radius, students. MCQ question. Will lot of radius. When two radius put together, what do you call? Diameter. Yes, diameter. Two radius put together, diameter. Diameter can be in any way, like this, like this. Anyway, we'll have n number of diameters. So radius is done, diameter is done, circumference. Next, a part of circumference. What do you call a part of circumference? Please, this part. What do you call just this part? Yes, others I taught you all right. What do you call this, student? Just a part of circumference, you call it as arc. Yes, we call it as arc. Fine, just a part of circumference, you call it as arc. Next, you'll have to remember these are the things you'll have to remember. Next, we have sector and segment. What do you mean by sector and segment, students? Know the difference between these two. Sector and segment. What is sector? Sector will have radius plus arc, and segment will have, what about segment? Yes, chord plus arc. Good. Chord plus arc will give segment. Chord plus arc. So remember the word R and R, sector and segment, very important. Sector, radius plus arc. Now let me draw like this. Even this is a triangle. This is a triangle AOB. Look at triangle AOB. In place of base, students, instead of constructing base, they'll just leave it like this. If it's inside the circle, we use theorems. Even this is a triangle, but here we are like this. Okay, it is similar to. It's not exactly like triangle, but remember the concept. It's easy to remember like this. It's a triangle in center. Now tell me whether is this a segment or a sector? Is it a segment or sector? Angle AOB. Why is it a sector? Because AO and OA and O are radius. Then which is arc here? Arc is AB. Good. So this is sector. Next one. What is ACB? Sector or segment? Segment. Who told sector? ACB. I'm talking about ACB, students. What is ACB? Segment, right? Yeah. Why segment? Segment is chord. AC and BC is chord. Yes, AC and BC are chord. So let me draw these two triangles. I'll imagine it's a triangle. I've taken it common like this. AOB and like this. ACB. Like this. For both, the base is same. Base, or you call it as arc. Base or arc is same for both. AOB, ACB. Which angle do you think is greater, students? Which angle is greater, O or C? Just observe the triangle. Yes. Observe the triangle. O is greater. Isn't it open wide? Compared to C, O is open wide, right? So from here we have the first theorem. The first theorem states that angle formed on the center will be how much? Angle formed on the center is equal to twice the angle formed on the circumference. This is the first theorem. Which angle is formed on the center? Angle AOB is equal to 2 times the angle formed on circumference ACB. Angle ACB. So if AOB, if I write ACB as 50 degree, what's the value of AOB? If it is twice, it should be 100 degrees, right? What is the value of AOB? AOB will be 100. Yes. Here the concept is AB, arc is same. Okay, arc is same. For theorem 1, you don't have to write anything. Just remember center is equal to twice the circumference. Angle formed on the center is equals to 2 times angle formed on anywhere on the circumference. This C can be anywhere, but it has to touch the circumference. Or even like this. This. Is it touching the circumference? ACB? ACB is touching the circumference. You can apply the theorem 1. Now let us change this. What is center and circumference? What is center? Triangle. Angle formed in the center. Chord or segment? I mean sector or segment? In the center. It is sector. Is equals to 2 times. What is the triangle formed in the circumference? We call segment. So look, using one sector and one segment, we have a theorem. Sector will always be equal to twice the segment. Only when arc is same. AB should be same. Arc. This is the first theorem. Center is equal to twice the circumference. Next. Yeah, Joanna, Cherisha, Lemula, and Naomi, you all shouldn't forget the students. This is the second time I'm teaching you all. Okay. Yeah, that's the reason I told you to attend at 5. Only if I teach twice, we'll be able to remember it. Next. The same concept, I'll draw another triangle. Another triangle. And along with this, we'll be using even triangle concept, isosceles, equilateral, all those things. Fine. With this, okay. Now tell me what are the two triangles we have. Tell me the two triangles, students. We have triangle AOB and no ACB, right? So for both, which arc is same? What's the base which is same? AB is same. So AB is the arc. AB is the arc. Here you'll have to always target the arc, students, which is on circumference. Fine? Arc. Now this AOB. What is AOB and ACB? Segment or sector? How are they formed? Segment? Yes. It is formed using chord, right? It is formed using chord. So segment. What about ACB? ACB is also segment. So this is another formula. Segment is equals to segment. The values will be same. AOB is equals to triangle ACB. That is nothing but, if ACB is 60 degree, what about AOB? AOB also should be 60 degrees. Both are 60 degrees each. AOB is equals to ACB 60 degree, and the reason is angles. Both are angles of same segment. This is the reason you have to write. This is theorem 2. Angles of same segment are equal. Angles of same segment are equal. Only if the base is same, students. Only if the base, that is arc, should be same. AP is same here. This is second theorem. Angle of same segment. You should remember like this: segment and segment. Okay, segment and segment will be equal, and both are formed on the circumference, not on the center. So circumference is equal to circumference angle. Okay, next, there are different ways to answer. Fine. Can you see CB is given here? CB, but A and B is not joined, right? Is A and B joined? Line A and B. Have I connected line A and B? No. So that cannot be a triangle. You can't see from that point of view. You can't see. You shouldn't take CAB. Look, you shouldn't take the CAB because I didn't connect. Even in the exam, you are supposed to take ACB. ACB. It is very simple. You all should have two sides, students. You should have two sides in any triangle. For example, ACB. AC is one. I mean, not two sides, two chords. You should find out those chords. AC is one chord and BC is one chord. Therefore, AB becomes arc. AB becomes the arc like this. Okay, I'll give you all one question. Try this question. See, mean chapter is almost done. Only 2 or 3 questions left. And after 7, we'll solve them. This. Okay, tell me all the triangles formed, students. What are the different triangles formed? Triangle ADB is one. Next. AOB and triangle ACB. We have 3 triangles. Okay, these 3 triangles. Tell me which is chord and which is segment. I mean, segment and sector. Which is segment out of these 3? Which one you call segment? Is ADB a segment or a sector? Segment. AOB? sector, and ACB segment. See, now I'll tell you all the reason. Whenever the base is not connected, in ADB is the base connected? Do you have the base, students? ADB is base connected? No, right? Look, this AB, is it connected? Have I drawn a line? This green line. Initially, did I connect it? Look, I'm talking about this ADB. So AB is not connected. If it was connected, we call this triangle. We would have called it triangle. But when it comes to circle, they won't connect it, students. ADB. We don't call triangle. Just for explanation purpose, I'm telling you to assume. We actually call that as segment. That's the difference. Actually, triangle segment is almost the same. If it is inside the circle, we call it as segment. Look at AOB. AOB is also triangle if it has base connected. Look, if the diagram was like this, AOB, we would have called it as triangle. But the base is not connected. Instead of base, we have arc AB. Therefore, we call this as sector. In the same way, ACB is a segment. That's the difference. So, sector segment is also similar to a triangle. It will not have a base. Instead of base, it will have an arc. That's the difference. Did you understand the difference between triangle, sector, segment? Yes. Okay, it's the same, but it won't have base. Look, I can draw a triangle like this. Look, this becomes a triangle. If I join like this is not a sector or a segment. This is a triangle. POD. Let me take POD is already given. I'll take it as R. Look at POR. We don't call POR a segment or sector because all three lines are connected. How many sides does it have? POR has how many sides, students? How many sides? Three sides. So therefore we call it as triangle. Okay, even though OR and OP are radius, OP and OR are radius. PR is chord. We don't call it as sector or segment. We call it as triangle. This is the difference. You all should understand. So when you look at the diagram, when I'm explaining, it would seem to be easy, but actual diagrams are totally different in the textbook or the questions which they ask in board exam. You should be able to figure out which is triangle and which is sector and segment. Now look here, I'll give a value. You'll have to explain each and everything in detail. Okay, find out the sector, segment, and triangle in this. I want all of you to find out sector, segment, and triangle. There are a lot of diagram, students. I'll give you 2 minutes time. Find out all the sector, segment, and triangles. Naomi, Joanna, I want you to try. Even let me learn. Okay, try this too. Okay, done. So we'll have lot of triangles, not one. All of you are done. At least one or two students, one or two questions we will try. Triangle, sector, segment. Okay, Naomi done. Yusuf, Diyashri, Lemula. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 students. So triangles. We'll start from triangle. It is easy to identify triangles. Tell me triangle. Any triangle. GSQ. Correct. GSQ is a triangle. Can you see GSQ, all of you all? Does it have only three sides? Yeah, there is no arc involved. GSQ is one. Someone else, can you tell me other triangle? There are a lot of triangles in this. Which is the other one? QP. Very good. QPG is also triangle. It has three sides. Okay, it is a triangle. Next. Next one. There is one more triangle. ESF. Yes, correct. ESF is also a triangle. Only if you are able to figure out triangle, pick out triangle, you'll be able to figure out segment and sector, where you can apply theorems. ESF is also a triangle. Okay, all these three triangles are made up of what? In terms of triangle, we call it as sides. But in terms of circle, what are they made up of? GSQ. What is GS? What is SQ? And what is SG? See, SNG doesn't have any value, right? SNG. Do we call it as a chord? SNG students. Look at SNG. Do we call chord? GS. No, right? No. What about SQ? Do we call it a chord? Chord or radius SQ? No. What about QG? What is QG? From one point to another point, called as chord. So a triangle can be made up of three chords, or it will simply have only one chord. You should always figure out the sides. Number of sides will be three. Lemula, did you understand? Not only in this, we have lot of chapters which will have circle, chord. There you all shouldn't forget. Next, let us take QPG, students. Look at QPG. What is QP? Q and P? Chord? Yes. GP is also a chord. GP is also a chord. What about QG? QG is also a chord, right? QG is also a chord. So this triangle is made up of three chords. In the same way, ESF, E and F is the only chord, students. Only E and F is chord. SF and F are not chords. They're just lines. They're not chords. So this is triangle. Correct. What you told was right. Next, let's target segment. For segment, always start with the arc. Is EF arc? See, EF can also be considered as arc, right? The outer one, arc. Yeah. Is it touching? We'll start from EF. All of you look at EF, students. Forget about triangle. We'll take this arc EF. Okay. If you take EF, is it touching the center or circumference? Any triangle, is it touching center, circumference? No. It is also arc. EF is also arc if you consider as arc. Okay, but it is not touching the center or circumference. So therefore, no segment or sector is formed. Simple concept. No segment or sector is formed. Now EF is done. EF is done. Let us take E and G. We'll go in anti-clockwise. Let us take E and G. Okay, E and G is arc. Tell me what are the segment and sector formed? ESG. Sorry, E and G. Segment. Very good. EQG is the segment. All of you look at EQG. EQ is arc. EQG is the segment. Any other thing? Segment. EQ. When I talk about EQ, students, what are the things formed? EQG and one more thing on the same arc. Check if any other thing is given. Sector is given. Yes, only one student is answering. What about others? You all didn't understand? EOG is there. Sector. All of you understood. So, which rule can we apply here, students? Which theorem can we apply? Segment and sector. Both have same arc. EQ. So, what is the theorem here? Center is equals to twice circumference. Yes, that's it. So you pick any arc, you pick any triangle, you should be able to answer the theorem. I mean, theorem is only for arc. You pick any arc here, EQ. You can randomly choose an arc, student. Check whether segment and sector is formed. That's it. So according to the formula, center. So if center is 100, this is how you do. Center triangle EOG is equal to triangle EQG 2 times EQG. So 100 is equal to twice EQG. What will be the value of EQG? 100 divided by 2? It should be 50 degrees. Yes, it should be 50 degrees. This is the concept. Check if there is any other given on EG, EQ, EG student. Sorry, I'm supposed to write EG here. Any other triangle on arc EG? No, right? There's no triangle. We had only 2 triangles. Even in that 2 triangles, you have to check whether it is a segment or sector. If it is segment and sector, apply the first theorem. Center is equal to twice the circumference. Okay, now that is got in anti-clockwise direction. Let us take another arc, GP. GP is also an arc. Look at this, GP. Tell me any Sector or segment formed in GP, students. Check. Check where is GP connecting. Where is this GP connecting? GQP. Anywhere else? Is it connecting any other triangle? Is it making any other triangle? No. So you can't form any theorem 1 or theorem 2 on circumference GP. Let us take the other arc. PQ. Look at PQ, all of you. PQ is the arc. Observe PQ and tell me any other triangle formed on PQ. QGP. Anything else? Sure, nothing else, right? Nothing is formed. So only segment is formed here, students. This is only segment. So this is what you call a segment. QGP. It can be anywhere. You have to start in a. You can go and clockwise and anti-clockwise. You should learn how to figure out triangle, segment, and sector. Okay, let us take the last arc. What is the last arc left? Tell me the last arc. Arc FQ. Yes, check if any segment or sector is formed. FQ. Which one? Very good. FGQ. FGQ. What is it? Sector or segment, Charisha? FGQ. Segment. So F and G is a chord. F and G is a chord. G and Q is a chord. F and G. G and Q. Two chords. There is no base. There is no third side triangle. Therefore, you consider it as segment. Don't tell it as a triangle, students. It is a segment. And it is not touching the center. Okay, it's not touching. This is how you figure out triangle. Difference between triangle, segment, and sector. Okay, try this question. APQ is 30 degree. Find ABC and AOC. Be quick, all of you try to solve this question. Yes, Emmanuel. Oh, Q is not. Sorry, it is APC, not Q. APC. Adia, when did you join, Adia? You didn't even inform, I didn't even know that you're there. What you would have understood? Yeah, again, you joined in between when I was teaching. Fine, you do. Yeah, you do one thing, Adia. Log in at 7. This entire 1.5 hour recording I'll send you. Yeah, I told you, I forgot. Now I saw your name. You should have let me. You should have told me that you have joined, right? Okay. Anyways, I'll send this, Adia. No problem. I'll send this. If you want, you try. If not, 7 o'clock we start main chapter. Okay, fine. But you have to go through this recording. 1.5 hour class. You should go through later. Try to complete today and tomorrow. Ask about 40 minutes to work, so that you'll be able to solve tomorrow's question. Okay. AB is 30 degree, students. Find arc, segment. Instead of you finding the arc or segment, see what they have given. APC is what they have given. Tell me whether it's arc, segment, or triangle. segment. Yes. Go do it in the opposite way. You don't have to find anything. Whatever they give, check what they've given. APC is a segment. Fine. If APC is given, which arc you have to target, students? In APC, which is the arc? AC. Always target arc AC. Whatever they've given, target that arc AC. Check if any other triangle is formed. What are the other triangles formed on arc AC? ABC. Is it a sector or segment? ABC. Segment. If both the segment have same arc, what will be their value? Both are equal. What is AOC? Very good. What is AOC? Sector. For all, yes, for both the sectors, AC is the arc, right? So which one is greater here? Forget about sector and segment. You just observe the triangle. Which triangle is greater, AOC or triangle APC? Which seems to be wider? Yes, AOC is wider. AOC is wider. From that we get to know that AOC is center. So definitely AOC center will be equal to twice circumference. This is how we have to put the questions. You don't have to find arc or triangle. Whatever they give, just connect it. Just figure out whether it's arc or triangle. So I've explained all this, students. Now that is easy. I've spent almost 1 hour, and for other students, almost 1.5 hours. So you shouldn't forget all this concept. Okay, now I'll tell you how to answer this. You can take any triangle. First thing, ABC they have asked. Let us take ABC. Okay, if ABC is 30 degree, what about AOC? What will be the value of AOC? 30 into 2, 60. So first thing, find the answers. Next, you write the statement. ABC is formed in the center. So ABC will be twice of which angle? APC. ABC is twice APC. So triangle A, not ABC. What is this? ABC. It is not twice. ABC is formed on the circumference. Look at ABC. Is equals to triangle APC. What will you write, students? What's the statement you have to write? Both are angles of same segment. Yes. Angles of same segment. That's the difference. I mean, this is the difference between sector, segment, and triangle. Next, they have asked AOC. Write AOC. Check AOC. AC is the arc. Is anything related? Yes, we have AOC is equal to 2 times. You can write anything. You can write even 2 times ABC. It's the same, right? ABC and APC both are same. So AOC is equals to, you can write 2 times ABC or twice APC. It's the same. 2 into 30. The answer is 60 degree. Answer is 60. That's it. This is how you solve it. Fine. Even tomorrow I'll teach. 2 theorems I've done. Tomorrow there are another 2 or 3 theorems. I'll complete. Then we'll start solving the questions from day after tomorrow. Or mostly tomorrow itself we'll start solving the questions. Is it clear, all of you? Any doubts in this? Okay, fine. Then who had to leave? Take 10 minutes break, students. 10 minutes break. 7 o'clock we'll start main chapter. Cherisha, not Cherisha. Yeah, Diyashri and Tanishka can leave. From 7 to 7:30, I'll be solving main 2 questions. Go through the recording. If not, keep it as pending. Yeah, check that later. You all can leave, students. Yes, bye. Yeah. Adya, from 7 o'clock you can continue, Adya. Okay, all of you will take 10 minutes break. 7 o'clock we will continue with the main question. 1 or 2 questions is left. We'll continue that.